Hello, welcome back. In the last class, we discussed about the basic definitions in morphology. I also gave an image example how different set operations can be performed, and we also discussed some terminologies like hit, miss, or fit, and also what do we mean by structuring element. Okay, so let us continue this discussion. So in the last class, we just used a term called structuring element. Now, structuring element can be of any size and also it can be of any shape. However, uh, for simplicity, we'll usually use a rectangular structuring element, and that too, the size is odd size. For example, in this case, it is 3 cross 3. So this will be the origin. So whatever we have marked here, this will be the origin. So when we perform operation with respect to this origin, we are going to perform. So this is also a 3 cross 3 structuring element, but notice here that in this case all the pixels are on, whereas in this case only the 4 neighbors of the pixel are on, whereas these are off, in the sense the values are zeros. So this is another example where you have taken a 5 cross 5, and you can notice here that some pixels are on and other pixels are off here. So we can use any structuring element of any size and also any shape. So you can observe here, this looks like a diamond shape, which means these values are zeros. Now the concept of fitting, hitting and missing is explained in this image, since we have discussed this already. Now notice here that suppose if I use this as the structuring element and try to see the operation of fit or hit or miss, notice here that this is a fit, because all the on pixels of the structuring element, they are actually overlapping with all the on pixels of the image. All the pixels are ones here. So this is a fit, and of course this is a hit, because some of the pixels in the original image, they are coinciding with the pixels in the structuring element. So you can notice here, this is overlapping with this is, so if even one pixel uh, overlaps with the structuring element, then we can say it is a hit. And in this case if I use this as the structuring element, then it is a miss, because notice here these are all ones and the corresponding terms here, elements here, they are all zeros. So which means there is no on pixel of the image overlapping with the on pixel of the structuring element. So not even a single pixel is overlapping. That is why this is a miss for this structuring element. But if I use this structuring element and try to do the same thing here, it will be a hit, because you can observe this pixel overlaps with this. So like this, by observing the image, the corresponding structuring element, we can say whether there is a fit, hit or miss. One of the uh, morphological operation that we perform is called dilation. Now let us consider an image example here. So dilation is a set operation. Now let us assume that we have two sets A and B. Both are from Z2. Dilation of A by a set B is denoted by the notation A B, which is defined like this. So let us understand this equation here. So we have already seen these operations. So as we have seen, B tilde is a reflection on B. That means all the elements of the set are multiplied with -1. So it is reflection about the origin, and this operation is translation, that is shifting by value z. So after reflection we are shifting by z. So this operation together, that means reflection followed by shifting, is called dilation. So all those elements of set A dilated by B is the set of displacement Z such that B and A overlap by at least one element. So let us try to understand this with an image example. So again here assume that the dark shade pixels are ones and the light shade pixels are zeros. So we use a structuring element of size 3 cross 3. Again here the dark shade pixels are ones and the light shade pixels are zeros. So when I put this structuring element on each of this, for example, let us consider this area. So as you notice here, these pixels are ones in the structuring element. So observe here, none of the pixels of original image which are on are coinciding with the structuring elements which are ones. So in this place I can replace, since it is a miss, as you can see, so it will have 0 color here, so this will be 0. Now suppose if I shift this by 1 pixel to the right, that means here. So when I put the structuring element here, so you can notice here these are ones. Now observe here, these 2 pixels which are on in the structuring element are overlapping with on pixels in the image. Therefore there is an overlap. So that is why this pixel will be made equal to 1. Okay, so originally this pixel was 0 and now it has become 1. Sorry, this has become 1. So similarly, for example, if I consider this region, again you can see that there is an overlap of 4 pixels. So the corresponding pixel here, of course it's already 1, so it continues to be 1. So what you notice here is, apart from the original region where all the pixels are on in the image, we have added some new pixels which have become now ones. So these are all the new pixels. Okay, so like this we will get a dilated image. Okay, so this is the operation. The symbol that is used for dilation is this. B tilde is reflection and this operation is shifting. So here B is called the structuring element. So we are obtaining reflection on B about the origin, that we are shifting by some value Z. So dilation of a set A by B is set of all coordinates. They are displaced such that we have overlap by at least one element. So if I have at least one element overlap, we will make the corresponding pixel one. So let us observe here. This is the original image. You can treat these as the white pixels. That means these values are ones. These are all ones and these are all zeros. Now this is a 2 cross 2 structuring element where these are ones and this is 0. Now reflection means this is what happens. So after reflection we are translating, that means we are shifting this along the lines here. So what happens is when I move this, for example, if I keep this structuring element overlapping with this, notice here that this pixel which was originally 1, of course it is overlapping with this pixel, therefore it continues to be 1. Now if I move the structuring element to the next position, say this position, originally this pixel is 0, but notice here that the structuring element, this pixel is overlapping with this, so which means there is one pixel overlap. That is why this has become 1. This has become 1. That is why this dark shade pixel is a newly added pixel. This is a newly added pixel with value equal to 1. So which means in addition to the original shape of your image here whose values are 1, few more pixels are added. So we have added few more pixels because of the dilation operation. So this is an example on dilation. For example, if I have image of size or width d, height d, and I use a structuring element of say width d by 4 and height d by 4. When I apply this structuring element on the image d, now because dilation is going to introduce some new pixels, you can observe here that this is the original image A which has been extended or dilated, and depending on the size, so you can see that you have dilated by d by 8 here and d by 8 here, so totally you would have extended the image by d by 4. For example, if I take the structuring element of this shape, this is the original which is shown in dotted line, and you have extended it by another d by 2 on either side. So this is how dilation is going to insert or elongate the original image depending on the size of the structuring element. So a good example, as you can see, this is the original image, and if I use a 3 cross 3 square structuring element for dilation, you can notice here that the width, okay, so the width here is increased, and if I further increase the size of the structuring element, you can observe here the width has increased. So this is actually what happens in dilation. Now a good example of this dilation, suppose if I have a text, because of poor resolution you can see that there are breaks here. Notice that there are breaks here. Now if I perform dilation on these type of images, notice here that the breaks that you had in the original image are now filled. Okay, so this would help in better recognition of the character. So this is the structuring element used here. Okay, so what for is dilation used? It can repair the breaks like this. As you can see, there is a break here which is filled here because of the dilation operation. And if you have some intrusions like this in the structure which has to be filled, I can use dilation. You can observe the intrusions are filled, almost filled. So like this we can use dilation for either repairing the intrusions or the breaks. Okay, so in the next class we will be discussing another operation which is opposite to dilation, called erosion.